What's up, guys? Let's learn a little bit more about REST with the help of some examples. So, what is a REST API? So, the client's program will use a web API to communicate with the web servers, right? As you can see in this example, we have a client which calls a web server, which then calls our backend servers and returns a response, right? And a web API takes a client's request, interacts with the backend servers, and responds back to the client. And many of today's APIs can be classified as REST APIs, and we will look into the REST architectural style of developing APIs. So, many programming languages and protocols use CRUD operations for manipulating data. So in SQL, we use insert, select, update, and delete. But similarly, in REST, we use CRUD, which is create, read, update, and delete. And CRUD operations can be easily mapped to major HTTP methods, right? So for CRUD, we have create, and the method for that is post. So post, we create new resources or data. Read in CRUD corresponds to get in HTTP, so you can retrieve data from the server. Update corresponds to put or patch, and it's used to update a resource. And then delete corresponds with HTTP delete, right, which is used to delete a resource from the server. So things are easily mapped over with HTTP and CRUD. And what makes an API RESTful? In the last video, we studied REST constraints. Now let's revisit those constraints from a different perspective. We'll see how an API should follow those constraints that make them a REST API. So the constraints in the last video were client server, cache, uniform interface, it being stateless, having a layered system, and also code on demand, right? So for the first constraint, client server, in the client server setup, communication is initiated by the client via HTTP protocol by calling different HTTP methods. And since the client and server are independent, those applications can evolve independently. And for the cache constraint, caching responses on the client side helps to respond to similar requests. So this reduces the client's perceived latency. And the cache header in the HTTP response is set if there is a need to keep the response data on the client, right? And there's also uniform interface. So this constraint enables different components to exchange data in a standard way. So therefore, there is a need to have a protocol that provides a standard way of communication. So fortunately, we have HTTP and HTTP methods. And similarly, the response also has a standard format. So HTTP methods have a name, URI, a version, a host name, and data sections. So this allows for a better uniform interface, right, for REST. And just so we know, what does a RESTful API client's request contain? So the request will contain a URI, a unique resource identifier, right, to access a resource requested by the client, so the server knows like what the client's talking about. And you have our HTTP methods, so developers prefer to use HTTP to implement RESTful APIs because of CRUD, right? And these methods are used to tell the server what to do with the resources. And HTTP header, they're used to exchange the metadata with the server. So for example, some headers are used to exchange the client's information, the rate limiting details, request status, my bad, data formats, data parameters required for processing a request, and so on. And what does a RESTful API response contain? So the response will contain a status code. So it gives a clear picture of, to the client about the status of the request they made. And there's also a response message body. So the message body will include the resource representation. So just depending on how you requested the resource, it could be in JSON or XML, whatever the response is. And yeah, based on the request headers, the server will choose an appropriate representation format, right? Because it could be in HTML or anything, right? So then you also have the HTTP headers, which provides more context about the response, the server encoding technique, the data, content type, number of requests, and so on. So it's the metadata for that request response. And getting back to our constraints, right? Important constraint in REST is that it's stateless. So each request is processed independently without a need for prior data or information, right? So no data needs to be served or stored on the server, right? And also a layered system. So this allows users to deploy different services on different servers, right? So for example, deploying APIs on server 1, this could store authentication information on server 2 and storing data on server 3 and so on. So you could have like a layered system, right? You could have a API gateway, and then you could have your services, or you could have another application in between those two. You could have different layers. The client doesn't know whether it's connected with the end server or any intermediate server. So that stuff is abstracted away from our client. And the last constraint is code on demand. So this constraint is optional. The client can request the server for some scripts. All the script files and other objects are downloaded and rendered on the client side upon a user's or client's event, right? So let's talk about best practices in REST. So firstly, exchange of data via JSON, right? This is a very popular textual data format in REST, right? The REST APIs should use JSON for sending and receiving data. Other formats like XML and YAML, they lack some common procedures for encoding and decoding the data, but there are plenty of server-side technologies that offer built-in methods to parse and manipulate JSON data, so json.parse and json.stringify. Just as a note, whenever the data is sent in JSON format to the client, the server should set content type in the HTTP header to application JSON, right? Because there are a lot of different ways we could represent this data on the client side, so you want to make sure you set in the HTTP header what representation to view this resource, right? So REST APIs can support a variety of file formats, as I said. So there's application XML, form URL encoded. There's also HTML and so on, PDF. So there are a lot of ways to represent our data. So nesting on endpoints is a best practice. So different endpoints containing the associated information should be interlinked to make them easier to understand. So for example, imagine a platform where multiple users can post their articles, right? So we have example.com/posts/user, right? And say comment ID or post ID/comments if we need to get comments for a post, right? So say we have two different functionalities, right? So one is if you want to get posts for a user, right, which is here. And then if you want to get a post's comments, that should look like this. So it's still part of our posts umbrella, right? And then you can add on these endpoints, right, to find the comments for a post, right? So you should use nouns instead of verbs in the path, right? So in the last slide, right, this is our path, and these should be nouns and not verbs, right? So we should avoid using verbs instead of nouns in the endpoint. So verbs represent methods. Like the HTTP already has these methods, while the noun represents the actual resource. So, for example, if you have get user, right, that doesn't really make sense because you already probably have a get in your HTTP method, right? This is kind of redundant. You don't really need this get. So you should instead call it like noun, so user or posts, right? So that kind of represents the actual resource. And error management and standard error codes. So we should use HTTP status codes regularly when an error occurs to indicate the nature of the error. This helps the API consumers understand the problem and handle it on their end. So you should also add an error message with the status code to help users, take some good corrective measures. That is important. So filtering and pagination, sometimes the database gets really, really big and fetching data from the database becomes really time consuming and it reduces our performance. So filtering reduces the request information from the server and also the latency. So for example.com/posts question mark Fahim, right? So fetch the post authored by Fahim instead of fetch all the posts, right? So paginating data also to reduce partial results or to fetch partial results at a time to minimize the page loading time. So if you have a really big database, instead of grabbing the whole database, just grab the first chunk of the database, right? And this is used to reduce the usage of server resources and increase performance, right? So adopting standard security practices, we should make our API invulnerable to malicious attacks. Communication between the client and server should also be private. For this example, in HTTPS, we can use that, which runs on top of SSL and TLS, which makes our request response information encrypted. So there's no middleman attacks. So, for example, HTTPS example.com runs on TLS while HTTP does not. And API versioning is also a good best practice. So you need to offer different versions of the API if we make any changes that might affect our customers. So in the V1 endpoint, it still may be useful for individuals who don't want to migrate, while the V2 has additional features and it can benefit those who are ready to switch. So adding a /V1 or /V2 to the path is a good way to, offer different versions or do versioning on your different endpoints. So API documentation is also a good best practice. So it's good to have comprehensive API documentation to help developers and other consumers understand the API and how to use it in their applications. So good API documentation has the following. It has detailed and clear explanation of API endpoints and their functionality. It has an SDK implementation provided in several state-of-the-art programming languages. It has clear instructions related to the integration, clear updates on the API lifecycle, error messages, and proper status codes to convey clear information about the error, and so on. Whatever is really important to document should be there. So let's ask this question. Why is Hypertext Transfer Protocol HTTP an obvious choice for implementing REST APIs? So REST is an architectural style and it's independent of any protocol, right? But there needs to be a protocol there that follows our REST constraints, right? But fortunately, HTTP's logic matches some of the concepts of our REST style, right? Therefore, developers often choose HTTP for creating REST APIs, right? So let's list all of the REST constraints that are supported by HTTP, right? So HTTP operates in a client server model, right? And HTTP includes headers that mark whether an object should be cached or not. HTTP includes verbs or methods, right, that determine the desired action of the HTTP requests, right? Providing a uniform communication interface between the different entities, and it's also stateless, right? So it does match our constraints with REST like pretty well. And so there are advantages of using REST APIs, which are REST architecture influences how we view, edit, and transfer material online, right? So the preferred choice of many well-known web services is REST, and let's look at why. First of all, it's very adaptable. They're able to transfer data in a wide variety of formats and handle a wide variety of requests, right? It's very scalable. A web application's REST API will be able to swiftly handle the growing volume and variety of queries as it expands and adds more services. It's very compatible. REST APIs employ existing web technologies, and it's simple to create and operate. And a REST API just requires the resource's URL to request it, right? So let's summarize this. We discussed the features that make a REST API. REST APIs are protocol agnostic. HTTP is a widespread protocol adopted by REST APIs since they need a protocol, right? And the adoption of HTTP for REST API is that this protocol fulfills many REST architectural constraints. So client server, cacheability, statelessness, and uniform interface. And we also discussed some best practices for designing a REST API and the advantages that REST APIs bring. So let's do a quick quiz. So assume that we have a website called readitnow.com containing a list of book titles, IDs, and reviews. Our task is to define an endpoint to recommend books to users based on their reviews. What would a suitable endpoint for the reviews be? So we have a list of books, titles, IDs, reviews. Our task is to define an endpoint to recommend books to users based on their reviews. What would be a suitable endpoint for the reviews? So if you just want to get reviews for a book, so if you just wanted to get all the books, you could just do /books. Sorry, I haven't seen this question in a little bit. I have to remember what I wrote. Define an endpoint to recommend books to users based on their reviews. What would be a suitable endpoint for the reviews? Okay, so this just gets a single book. And if we wanted to just get reviews, then it would be B, right? So you could look at the books, look at its ID, and then get the reviews for that book. So I would say it's B, which it is. So hopefully you learned something. Thanks so much for watching. I'll see you in the next one.